a little video on the digital tester that I mentioned on part 4 of the AVO Mk2 videos that I've been doing. So I compared the results of the AVO Mk2 to the results I got on this little digital tester. This thing I put together probably 10 years ago from a kit. You can buy them in fully made in a little case. I put this one together myself from the kit that I got from the fellow. It's a very helpful guy in France somewhere that I got the kit from, and it works really, really well. So we've got the 9 pins, 8 pins valve sockets here. We can test a variety of tubes. It just depends on how you connect the electrodes to the pins of the tube. And at the moment, I've got them set for a 6L6 GC that I used on the AVO. So I'll just show you what sort of results I get from this. I've got it set up for 250 volts on the screen and 250 volts on the plate, and I've got minus 14 on the bias. So that's in line with the characteristics for these parameters for the 6L6 GC. So you got 250, minus 14. We should get 72 and around 6. Okay, so this tester will give you the current draw. Press this button, and if you look at the screen, okay, around 72, which is the value, the standard value that we should get. The values in red are the values I got on the AVO, so this matches pretty well. Now for the transconductance, what you need to do is change the bias by 1 volt. So we change that to minus 13, around there. Let's see what we get. We get around 77. $78. So if you subtract that from the previous value of 72, it's pretty darn close to 6. So this particular tube, which is the same tube that I used on the AVO 6L6 GC, is pretty much spot on with the results we're supposed to get. So I can change the parameters to this and see how close we get. Okay, so I'll change it to 300. That's plate voltage 300. About there. And for the screen, or grid 2, that should be 200. about there. And for the bias, we should set that to 12.5. Be about there. And the result we're looking for, current draw, is 48, which is what the value is supposed to be, and that's what I got on the AVO. We'll see how that compares. .47, that's very close, and if you adjust the bias to be correct, .48, .47, .48. So that's basically pretty much the same as that. Now for the transconductance, it should be 5.3. On the AVO, we got 5.6. So we do this again, change it by 1 volt. 11.5. Out there, we get 53, which is what, 5? Yeah, 53, and previously we got 48. So you're looking at 5. So what we're looking for is 5.3, but we got 5. And what we got on the AVO was 5.6. So very close, very close. Not a big deal. Now if we test the other one, which is 350, 250 minus 18, we can set that to plate. We want 350. And for the screen, grid 2, we want 250. And we need minus 18. Minus 18. Yeah. Okay, about there. Just adjust that a bit. Close enough, eh? About there. So the value we're looking for, the current draw at these parameters is 54. 54, and we got 52 on the AVO. We get 50, which is 2 milliamps less than what we got on the AVO. So again, that's very, very close, isn't it? Although, need to adjust this a bit to 50. And 18. Gone over a bit. 50 milliamps current draw, and what we're supposed to get is 5.2. the AVO gave us 5.6 and 52 current draw. So what did we get? 50. So it's still comparable to the results that the AVO gave me. So you can see that the accuracy between these two testers is pretty close. So, and I'm getting consistent results on both of them. So it all seems to match up pretty well. Okay. Turn that off. And that's it.